For the pneumatic circuit using cascade design, 9 cylinders were used at the carton box model unit and packing station. Double acting cylinder was used, 5 two-way valve and non-sustained type of valve was connected to each of the cylinder. So, in a manifold line 01, when PB is pressed, the air will flow through the 5 two-way pneumatic valve 2 and will trigger sensor B1 at the manifold line 01, which make the cylinder A and cylinder B will be extant condition, while the 5 two-way pneumatic valve will change their position to A plus and B plus, and air flow push the cylinder to fully extend. Next, for manifold line 02, after cylinder A and B fully extend, the airflow will through the 5 two-way pneumatic valve 3 and it will trigger sensor C1 and manifold line 02, which make cylinder C extend condition. Then, it will trigger sensor A0 and B0 that make the cylinder B and A retract. Then, for manifold line 03, after cylinder C fully extend, air will flow through the 5 two-way pneumatic 4 and it will trigger sensor F1 at manifold line 3, which make cylinder F will extend condition. Then, it will trigger sensor E1, which make the cylinder D and cylinder E extend condition. After that, it will trigger sensor C0 that make cylinder C retract. While for manifold line 4, after fully cylinder F extend, airflow through the 5 two-way pneumatic valve 4 and it will trigger sensor H1 at manifold line 4, which make the cylinder D and cylinder E retract, and cylinder A will extend after detect sensor E0. Then, the sensor H1 will detect and the cylinder G and H will be extend condition. Next, for manifold line 05, after cylinder G and H fully extend, airflow will through 5 two pneumatic valve V and it will trigger sensor H1 at manifold line 5, which make the cylinder I will be extend condition. Then, cylinder G and H will be retract. At the end, for manifold line 06, the airflow will through 5 two pneumatic valve and it will trigger sensor I1 at manifold line 6, where cylinder I will be retract and retract back at the cylinder B.
From the later diagram, electro-pneumatic circuit could be constructed in the fluid sim software. In the pneumatic circuit, 9 cylinders were used at the carton box's molder unit and packing station. Double-acting cylinder was used. 5 to two-way valve and no sustained type of valve was connected to each of the cylinder. In the electro-pneumatic circuit, for retract operation, roller switch was used, and for extend operation, proximity sensor was used. Start push button and K23 will activate group 1, K1, and the holding circuit K1 will hold the circuit. K1 will allow current to the solenoid valve A plus and B plus and energize the solenoid coil. It will actuate A plus and B plus at the 5 to two-way valve and allow air to flow to the cylinder A and B. Cylinder A and B will extend. When cylinder A and B is fully extend, K8 will activate. K1 and K8 will activate group 2, K2, and the K2 will hold the circuit. When K2 is activated, normally closed K2 will deactivate K1. K2 will allow current to flow to the solenoid valve B minus and energize the solenoid coil. It will actuate B minus at the 5 to 2 way valve and allow air to flow to the cylinder B. Cylinder B will retract. When cylinder B is fully retracted, K9 will activate. K9 and K2 will allow current flow to the solenoid valve A- and energize the solenoid coil. It will actuate A- at the 5 to 2 way valve and allow A flow to the cylinder A. Cylinder A will retract. When cylinder A is fully retracted, K7 will activate. K7 and K2 will allow current flow to the solenoid valve C+ and energize the solenoid coil. C+ at the 5 to 2 way valve will actuate and allow current flow to the cylinder C. Cylinder C will extend. Group 3, K3 will activate when cylinder C is fully extended. K2 and K12 will activate K3 and holding circuit, K3 will hold the circuit. Normally closed, K3 will deactivate K2. When K3 is activated, it will allow current flow to the solenoid valve C- and energize the coil. It will actuate C- at the 5 to 2 way valve and allow air to flow to the cylinder C. Cylinder C will retract. When cylinder C is fully retracted, K11 will activate. K3 and K11 will allow current to flow to the solenoid valve D+ and E+ and energize the solenoid coil. It will actuate D+ and E+ at the 5 to 2 way valve and allow air to flow to the cylinder D and E. Cylinder D and E will extend. When cylinder D and E is fully extended, K14 and K16 will activate. K3 and K14 will allow current to flow to the solenoid valve F+ and energize the solenoid coil. F+ at the 5 to 2 way valve will actuate and allow air flow to the cylinder F. Cylinder F will extend. When cylinder F is fully extended, K18 will activate. K3 and K18 will activate group 4, K4, and holding circuit K4 will hold the circuit. Normally closed, K4 will deactivate K3. When K4 is activated, it will allow current to the solenoid valve D- and E- and energize the solenoid coil. D- and E- at the 5 to 2 way valve will actuate and allow air to flow to the cylinder D and E. Cylinder D and E will retract. When cylinder D and E are fully retracted, K13 and K15 will activate. K4 and K13 will allow current flow to the solenoid valve B+ and energize the solenoid coil. B+ at the 5 to 2 way valve will actuate and allow air to flow to the cylinder B. Cylinder B will extend. When cylinder B is fully extended, K10 will activate. K4 and K10 will allow current flow to the solenoid valve F- and energize the solenoid coil. It will actuate F- at the 5 to 2 way valve and allow air flow to the cylinder F. Cylinder F will retract. When cylinder F is fully retracted, K17 will activate. K4 and K17 will allow current to flow to the solenoid valve G+ and H+ and energize the solenoid coil. G+ and H+ at the 5 to 2 way valve will actuate and allow air to flow to the cylinder. Cylinder G and H will extend. When cylinder G and H are fully extended, K20 and K22 will activate. K4 and K20 will activate group 5, K5, and holding circuit K5 will hold the circuit. Normally closed, K5 will deactivate group 4, K4. When K5 is activated, it will allow current flow to the solenoid valve H- and energize the solenoid coil. H- at the 5 to 2 way valve will actuate and allow air to flow to the cylinder H. Cylinder H will retract. When cylinder H is fully retracted, K21 will activate. K5 and K21 will allow current flow to the solenoid valve G- and energize the solenoid coil. It will actuate G- at the 5 to 2 way valve and allow air to flow to the cylinder. Cylinder G will retract. When cylinder G is fully retracted, K19 will activate. K5 and K19 will allow current to the solenoid valve A plus and will energize the solenoid coil. A plus at the 5 to 2-way valve will actuate and allow air to flow to the cylinder A. Cylinder A will extend. When cylinder A is fully extended, K8 will activate. K5 and K8 will allow current flow to the solenoid valve I plus and energize the solenoid coil. I plus at the 5 to 2-way valve will actuate and allow air flow to the cylinder I. Cylinder I will extend. When cylinder I is fully extended, K24 will activate. K5 and K24 will activate group 6, K6 and holding circuit, K6 will hold the circuit. Normally closed K6 will deactivate group 5, K5. K6 will allow current flow to the solenoid valve I minus, A minus and B minus and energize the solenoid coil. I minus, A minus and B minus at the 5 to 2-way valve will actuate and allow air to flow to the cylinder. Cylinder I, cylinder A and cylinder B will retract. When cylinder I, A and B is fully retract, K23, K7 and K9 will activate. Normally closed K23 will deactivate group 6, K6. When start push button is pressed again, it will repeat the same process.